Yeah, so I'm Andy Oliver. My company is Open Software Integrators. We're a sponsor. We've got a booth upstairs. And we also have a photo booth. So if you have ever wanted to post your own picture of yourself for the NSA as anonymous, we even have the mask for that. Good, way for us to all be anonymous, or at least as far as the NSA is concerned. And by anonymous, I mean they'll know who you are. So we've been in business since 2008, 2007, depending on who you ask. And we started out as a basic Java Linux kind of shop, doing a lot of Spring and all that kind of nonsense. And as this sort of revolution of big data and NoSQL and what have you started to go on, it's like, okay, we're doing all this stuff in the middle tier to make up for the fact that we're choked on the back end. So we really wanted to be a part of that, and we pivoted really starting last year, but pivoted from that to focused on strict Hadoop and NoSQL this year. And we are hiring, and we're looking mainly for people with a Java background to do sort of on the dev side, since Hadoop is written in Java. We will teach the people Hadoop. We're not dumb enough to be one of those places that goes, I need you to have like 10 years of Hadoop experience. So pretty much no one other than Doug Cutting need apply, So we're hiring mid to senior level. We're also hiring DevOpsy people. So people who know how to set things up and write Puppet scripts and Chef scripts and Salt scripts and a whole lot of other stuff I don't actually know. It is a traveling job because we're going to different companies and making this happen. Actually, the preferred list is sort of out of date, so ignore that. So we're going to talk about what Hadoop is anyhow, what it's good for, what it's not good for, how you get data into Hadoop, how you get data out of Hadoop, how you process data in Hadoop, how you analyze data in Hadoop, and how you secure Hadoop. To me, this is sort of the main thing that you need to know. This is an overview talk intended as a roadmap to point you to the most important bits along the way. It's not a comprehensive training. It's not an in-depth look at any one part of Hadoop because I don't have enough time. And it's sort of a high-level selective overview of the Hadoop ecosystem. One of the things I hate about most Hadoop talks is they'll go and sit there and say, and Hadoop is all about Yarn. We're hardly going to talk about Yarn at all because Yarn is really not that interesting from a what do I need to know to make this thing work perspective. It's like if I go to operating system talk and they only talk about the process scheduler. Well, that's exciting. Okay, my processes are scheduled. Good. So we're going to focus more about what you need to know to use Hadoop and go from there. This is an intro talk. I'm happy to handle any advanced questions or whatever, but that's where we're going to start from. So what is Hadoop anyhow? And this is actually the hardest question. So it's a platform for distributed computing. All right, what's that mean? So in 2011, if you'd have asked, we'd have mainly talked about HDFS and Hive. In 2012, we talked about HDFS, Yarn, Hive, Hbase. Now in 2014, not that some of these other things didn't exist, but if you were to ask somebody, they'd say, well, that's the main thing that people mean when they talk about it. Now they're talking about this whole ecosystem of stuff. So there's lots of different projects and what have you. We're going to focus sort of on the core bits and go out from there. So it no longer is really, when people say Hadoop, they don't really just mean HDFS and Hive, which is sort of the SQL interface, if you will. So we'll start with the beginning. What is HDFS? HDFS is a distributed file system. It's a distributed file system similar to Gluster and Ceph, et cetera. In fact, various vendors will actually sell you on replacing the HDFS component of Hadoop with Gluster or Ceph or whatever. I know that Red Hat does that, and there's also OrangeFS sponsors a lot of these things and what have you. So you can replace it if you wanted to for whatever reason you might want to. You can use other distributed file systems in place of HDFS. Blocks are distributed. So this is distributed at the block level mainly. Meaning, if I've got n number of nodes, you get a block, you get a block, you get a block. But then also I do things like making sure that no one node is the only copy of that particular block. So I distribute the blocks. I also have redundancy. That redundancy is configurable. That does mean that if you had like a 3 data node Hadoop cluster, so if you only had 3 nodes dedicated to data nodes, you wouldn't really have a lot of redundancy or any redundancy. And therefore, if one died, life just sucks for you. Or if you had a block get corrupted, then life would just suck for you. 128 meg default block size. And that's something to remember, right? 128 meg default block size. So your boss is like, hey, we're going to use Hadoop as our like file server. Store all our Word documents in it. And you're like, each one is an average of 1 or 2K, whatever. Only it's going to be 128 meg per doc, right? So you need to think about that, and there are ways to deal with that, but Hadoop is not good for tiny little files. Hadoop is great for really big files. It's optimized that way. Yes, that's configurable, but if you have that problem that you need much, much smaller block sizes, this may not be the technology for you or for what you're trying to use it for. HDFS has a RESTful API. It has, I'm going to knock this over, CLI tools, third-party tools to mount HDFS. So you can mount HDFS on Linux and use that as a file system, much like you would mount an NFS share or whatever. They're actually, the annoying thing about Hadoop is there's not just one way to mount it. We need, it's open source. We need like 10 half-thought-out ways to mount it, right? So you can do it as an NFS bridge. You can do it with Fuse, et cetera, et cetera. There's a CLI tools, and that's honestly what I use most. The tools to mount it, there are even available on Windows, and so on and so forth. Okay, so here is the statement. Do not put your data nodes on a SAN. Well, what about our company policy? Do not put your data nodes on a SAN. Because we're distributing for performance, for redundancy, et cetera, but then you're going to go bottleneck that all on a SAN. Yeah, EMC will tell you, oh, but we have these paths and blah, 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 blah. Well, why are you using a distributed file system if you're going to de-distribute the file system? You're going to end up with the worst case, or the worst of both worlds. You'll end up with the overhead of HDFS and the overhead of your SAN, and none of the benefits of either. So do not do that. Do not put virtual machines inside of virtual machines inside of virtual machines either. So we talked about Yarn briefly, yet another resource negotiator. It schedules work among the nodes. It distributes the processing. MapReduce is an API, and it's also an algorithm. It's an algorithm to distribute the work. So I realize that I'm going after all this data. I'm going to do all this processing with this data. I break it up into pieces. I distribute the question to multiple different nodes, and I then reduce the answer into one answer. That's a gross simplification, but it is a decent explanation. Hive is HDFS Hadoop-based data warehousing. So it stores, for Hive, you've got files on HDFS. They're text files, they're comma-delimited files, they're whatever. You can actually just directly say, Hive, I want you to represent this as a table. You can connect to Hive with JDBC or ODBC or using the REST API or what have you, and issue queries. These queries are then turned into MapReduce jobs and run against it. Those initial file formats of text file formats or whatever that you got from some other system may not be the most efficient format to store in, but Hive can work with fixed width, comma delimited, et cetera. Or you may have to reprocess them with other tools to get them into a more optimal format, or because you've got a weird fixed width format, or something is weird about your file that you need to transform it. And we'll go over those tools. There are no updates, deletes, or transactions in Hive in the current sort of production version. Those are coming. And this sort of, this is a little, you have to understand Hive was originally just for a convenient way to create MapReduce jobs. Now people are sort of expecting database-like functionality because they're connecting with JDBC and ODBC. And oh my gosh, when you're trying to do a file transformation kind of thing, and you're trying to get data in there, and you're trying to keep histories or what have you, and you're coming from other systems, coming up with a structure to work around the fact that you have no updates can be a pain. Because what if you want to just update this one little thing to say this is not the current record? Tough luck. There is no update in the production. The new version that will be coming out under the codename Stinger Next does start adding all these things, and ACID transaction, whatever, and so Hive is sort of evolving, or devolving if you wish, evolving into almost a full-fledged database. It's not going to be ever a transactional database like you would use for an operational system. It will always be more of a data warehousing style technology, we think. The other main thing that people talk about in the core of Hadoop is either Hbase or Cassandra or both. They are both column family databases. Hbase is ACID. Cassandra is really around heavy reads and writes, and has eventual consistency. They are both column family databases, but you use them for different use cases. And the full scope of that we can talk about in questions, but it's a little bit beyond this. So we come back to, now there's the big list of things. I didn't talk about Spark, I didn't talk about Tez, I didn't talk about all these other things. There's a whole big list of things, but basically Hadoop is an ecosystem of tools for distributed processing and storage of data. And it is really storage for distributed processing. And this is actually another thing that I see a lot of companies doing these days, which is they'll size the Hadoop cluster based on storage, because that's what they're used to doing with the SAN, right? So they're like, okay, how much disk space do I need? But that's really the wrong thing. I've really rarely run into a thing where our main problem is that we were running out of disk space until it got some maturity and a lot of use. Initially, what we're seeing is that people just undersize the number of data nodes and instead get really big disks with 5 data nodes. I'd rather have really small disks and have 100 data nodes than have really big disks and 5 data nodes. Well, that's an extreme, but I'd rather do that. I've seen Hadoop clusters with 1,000 nodes. Some of those have very little RAM and very little disk space per node, and those perform better than buying a bunch of big boxes, because what are we doing? We're distributing the processing. Well, guess what? When you have big disks and only a few data nodes, you end up being CPU bound. Imagine that. And that's part of the whole idea of a distributed file system, right? If I'm putting a block here and a block here, and I'm going to be reading all of those blocks, then rather than asking for the blocks in sequence, I ask for them at the same time, in essence. So what is Hadoop good for? Hadoop is good for working with large amounts of data in batch. It's good for ETL processing. It's good for data transformation. There's some people that use it strictly for ETL offloading because they've got their big expensive data warehouse, and their big expensive data warehouse to buy another CPU board or what have you is going to cost, more money than everybody in here makes combined, et cetera, et cetera. So some people are using it for ETL offloading and what have you strictly. Analytics and BI, business intelligence. Integration, and this is actually a big thing. So this is where the whole data lake or enterprise data hub, anything to avoid calling it data warehousing, where, gee, we've got a little bit of data over here, we've got data over here, we've got data over here. Well, when I go to my IT guy and I say, hey, IT guy, I bought this fancy new analytical dashboard, and I would really like a new feed from the operational system. You say, Hooray, yes, I would love to give you another feed to the operational system along with the other 100 feeds that people are asking right now that they'll all hit at end of month, right? No. You say, oh, you're going to need to talk to the security team, who are very skilled at having lots of meetings with you, and saying no. And then you say, please. So instead, what we're doing is hub and spoke kind of integration. So what we do is we start getting one feed from every operational system, putting it in this data lake or enterprise data hub, depending on whether you're Pepsi or Coke. Most of the vendors are calling it data lake. Cloudera is calling it enterprise data hub, and then you can kind of see alignment based on that. I think more companies are calling it data lake than enterprise data hub, but whatever. And they're drawing differentiators, but we're really talking about sticking all the data in one big place and getting everyone to feed from that rather than having everyone go to the operational system. We did this before, right? It was single sign-on and all these other things where we're like, let's not do point-to-point integration everywhere, right? We're going to do SOA, right? SOA will save us all from ever talking to each other. We'll just publish services. Okay, well, when we want to analyze something across all of these different services, you know, hey, what's 200,000 web service calls, right? So a lot of this is integration. The other thing that is sort of new and immature, quite frankly, we look at stuff like Kafka, and we look at Spark and what have you. These are working with streams of data or events. So sometimes you'll hear the word micro batches, which means we buffer and batch little batches rather than having big, let's go over big data. No, we're going to go over big data in real time, if you will. So this ends up being some form of messaging, publish and subscribe, and stream processing and what have you. So this is new to Hadoop, and these frameworks are evolving. They're a little immature, and I think that'll come out. They'll say, oh, well, it's 4 years old, but it's 4 years old and different level of commit from the different vendors. Time series data or similar data is also goes into Hadoop and what have you. And there's a lot of other things it's good for. But what is it bad at? Okay, so what's it bad at? Quick jobs. In that Hive and MapReduce setup time is measured in seconds to minutes. And so this is a frequent, you know, how do we optimize Hive? And it's like, well, what do you mean? You know, we just poured through 200, you know, terabytes of data in only a few minutes. That's a pretty good time, you know. Well, yeah, but we did select single row from table, and it still took about the same amount of time. It's like, yeah. The time it takes Hive to set up a MapReduce job is pretty much constant, meaning it's going to take seconds to set up a MapReduce job. So if you're used to saying select count from, you know, select one from dual, right? Select one from dual, if you had a dual table, would take about the same amount of time as select 100,000 rows from some large table, or some not very large table, but from some table, from the middle of some large table. As I mentioned, lots of small files. Remember that 0 size file, so you just do an echo dev null into a single file and upload it into Hadoop and into HDFS. And how big is it? It's 128 megs, despite whatever it says. General DBMS stuff. So Hbase is a much more specific. So people talk about, okay, well, I need ACID, so I'll go to Hbase, right? Well, Hbase is a more specific database than MySQL, et cetera, meaning it's not necessarily for any kind of problem that you can think of. Hey, time series is the one everyone says it's obvious. There's other types of data that it's also good for. But it is not the same as a relational database, or not necessarily for all the same problems if you're coming from relational database background. There's overlap with other types of databases like document databases and what have you, but it's not the same as your normal operational database. And a lot of people get into trouble trying to just do a one-for-one replacement. What we've come up with, what we've been doing wrong in the industry, and I gave another talk last year to this effect, what we've been doing wrong in the industry for many years is no matter what the problem was, it must be an RDBMS. That must be the answer, is a relational database. Why? Because that's what we do. Okay, well, when I go and write code or something, I don't say whatever the problem must be, the answer must be a vector, or the answer must be a hash table because I like hash tables, right? I like hash tables, so the answer must be a hash table. No, I've got different data structures for different purposes, right? Well, just because you're persisting it, you'll have different database structures and what have you. So what we're ending up with is, gee, we need a different system when we're trying to go analyze a large, huge amount of data. We need a different system for when we've got a lot of short, sweet transactions, and sometimes we've got a lot of heavy reads and writes, and the data doesn't have to be super consistent. Sometimes we've got, gee, it does need to be consistent, and it's time series and what have you. So we've got a lot of different types of problems, and we throw different types of persistence at it. That's sort of the explosion. The other thing is the economics have changed. It used to be buying a disk was very, very expensive. Buying a new server was very, very expensive. Managing all this stuff was a lot harder. We've got the tools and we've got some of the stuff now to make this stuff work, and the economics at play. This is usually where I have a picture that I forgot to put in here, where this guy's taking a 5 gigabyte hard drive off of an airplane with a forklift. So things have changed. What else is Hadoop not good at? High availability. And every vendor is going to come up and say, every Hadoop vendor is going to say, we nailed high availability last year because now you have HA name nodes and blah, blah, blah. Where the year before they would say, what is high availability really? So now we nailed it, except you nailed that the name node is HA and what have you. All of the other crap that you use with Hadoop may not actually yet work with HA name nodes. Stuff like, oh, maybe you want to do work, maybe you want to schedule jobs with Uzi. Oh, guess what? It doesn't really work that well yet with HA name nodes. Or maybe you want to secure, you want perimeter security with Knox. It doesn't, it totally ignores the second name node. So I would say it's not good at it yet. Can you do an HA for at least the core of Hadoop? Absolutely. Are there things that aren't really HA yet? Yeah. So how do you get data into and out of Hadoop? So how do you get data into Hadoop? Well, you can use Scoop, which Scoop is a pretty simple interface to any JDBC SQL-style database. It can work at other things in addition to SQL databases, but that's the main thing people use it for. You can use JDBC or ODBC and push it into Hive from an external database. You can push data into Hive with the RESTful API, and Hive will go and write to the underlying file on HDFS. You can put an extract file into HDFS with the REST API. You can just use straight curl to do this, if you like, which curl is a Unix command line tool to make REST calls or HTTP calls. You can process it directly in the Hive with the load data statement. So if you already had a file on HDFS somewhere, you can say, Hive, just go load that file. And if it's something Hive knows how to read, it'll make a table representing that file, or you make the table with the DDL statement, but it will load that into your table. It will make that the backing file. You can transform or process it into Hive using Pig. You can use Java. You can message it there with Kafka, which is basically a messaging style platform built on Hadoop. You can use RabbitMQ or a similar MQ, or a custom spout for something called Storm. You can use any multitude of APIs to write into HDFS, Hbase, Hive, etc. How do you get data out? Well, the first question you need to ask yourself is, should you be getting it out? Because this is actually an argument I have all the time. We had this on a project I was working with. The test team was going to, and this, they weren't doing automated testing so much as the old style, let's hire thousands of people offshore to test this kind of thing. So labor was cheap and knowledge was expensive in some cases, in this particular case. So what they were doing is trying to pull down the entire file. Okay, well that'll work for day 1. By day 10, we're going to have a huge file that you're planning to pull down onto your Windows desktop. and then use an editor to find things in it. So the question is, should you be doing that, or should you find a way to use command line tools or use Hadoop itself or what have you to do what you're doing? Should you really be pulling the file out, or should you find a way to process it, whatever you're trying to do with the file, within Hadoop? You can use JDBC and ODBC to Hive to pull data out. You can use Hbase, can be mounted. So if you've got something in Hbase, it can be mounted into Hive. So you can do it that way. There are, of course, REST APIs and what have you to Hbase. But if you needed that sort of connectivity, you can do that. REST APIs for Hive and HDFS. There are APIs for Kafka, Spark, Storm, et cetera, et cetera, et cetera. HDCP is a command line tool to copy from one Hadoop file system to another Hadoop file system. You can mount it with Fuse or your favorite Linux tool. And then you can do fun stuff like this, which is, this is just using Hadoop at the command line to cat some file. I'm grepping the file for stuff, and I'm outputting it to a new file locally. So you can do that if you want to. You can also, I could actually pipe it to some file in HDFS if I wanted to, but I was talking about getting data out. So how do you process data in Hadoop? Well, there's a MapReduce Java API. Hive supports SQL. Pig can munge files in HDFS and can work with Hive. Storm and Spark have their own APIs for dealing with events or micro batches of data. There are also numerous toolkits. So there's Mahout, so if you want common machine learning algorithms. And this is where your math geeks get up there. Oh, you know, if you ever watch that show Numbers or whatever, where they reinvent everything that the FBI does as a common kind of thing, as if they first thought of it. So the mathematician, well, I could figure out where the criminal lives by blah, 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 blah. And the math geeks are probably sitting there, no, that's wrong. And everyone else is like, you know, this is sort of a template for a show, right? Other times he's a computer genius, and he just goes, and then if you listen to the jargon there, like, oh, I'm going to connect to the mainframe. Wait, you're connecting to a mainframe, and this is a state-of-the-art system. Interesting. Like Battlestar Galactica, it's like the mainframe. It's like, that's not good. So the fun thing with Mahout is, and there's also imlib in Spark, which is another machine learning algorithm. Remember, this is open source. We can't have one. We have to have several separate implementations that are half done. So the fun thing about Mahout is, yes, okay, I can use a Markov structure to blah, blah, blah. The fun part, or the difficult part, is not actually even the math. It's setting the problem up to where you can actually do that. So getting the data into the format to where you can actually use it with this simple machine learning algorithm. But its implementations of those, all the hard work will actually be done by the not math geeks to figure out how to get the data set up for Mahout, and then, you know, the math geek may be the one who analyzes it and realizes, oh, this is the algorithm. I do this sometimes, and then the real math geek comes in and says, oh, why'd you do it that way? It would have been simpler to do. But it worked. Imlib is built on Spark. GraphX is a graph for graph problems. Most major BI tools now support Hadoop. So how do you analyze data in Hadoop? Most major BI tools now support Hadoop. Tableau, Pentaho, Datamirror. Your favorite is probably also on this list. But I don't have as much fun sitting here like putting slides full of every BI tool I can think of. But all of that stuff is for lamers. Use the command line interface, and you can just do execute select from some table, or you can do run a pig script against something, and all of that good stuff. You can use RStudio and write some R. R is a language, sort of a statistics language and what have you, to predict what sales will be next month. You'll probably be sort of wrong. Your favorite SQL tool that supports JDBC and ODBC, you can use Hue, which I'll show a screenshot of, which is sort of a GUI for Hadoop. And if you ask me too many questions about it, you'll quickly realize I am a command line geek and I hardly use it. So how do you secure Hadoop? So HDFS supports POSIX, which for the unwashed means Linux-style file system security. The most complete security authentication through Hadoop is based on Kerberos. And yeah, you're like, Kerberos, I really want to deal with that piece of crap again. But what you'll find out is all of the most thought or the most complete whatever throughout Hadoop is in the Kerberos implementation, even if you don't really want to deal with it. You can do straight LDAP, but it's very obvious that it's not integrated and that it was sort of done, oh, we need HDFS to support LDAP. Oh, we need this to support LDAP. Meaning if you go in and read the code, you'll find they each have separate implementations of the LDAP thing to like authenticate a user, look up his groups, and what have you. And they don't even do it in the same way. And in some places you're like, oh my goodness, you wrote this crap? Knox in particular. Knox supports perimeter-based security for only Hive, HDFS, Uzi, Hbase, and Hcatalog. You're going to be like, well, what about this other Hadoop thing? Only these so far. And if you actually look at what Knox is, and I like to trash Knox. If you actually look at what Knox is, it's basically a Java rewrite of mod rewrite, mod proxy, and basically mod LDAP, only in Java by someone who wasn't very good at writing those things in Java. However, it is the default. And he's laughing because it's like, oh, I'm the one who wrote it. But no, if you go look at that code, you're going to be like, really? And then when you get done and you think about it, you're like, wow, why didn't somebody just write a mod rewrite, mod proxy, whatever recipe for this? Because that would have been better. But it's not Java, so it's bad. Supposedly Argus, which is Hortonworks' acquisition, XA Secure, is supposed to save us from all this by creating a single identity to use through Hadoop and then put all the hooks everywhere. But they just bought it. It's not what we would call something that's been used in production in lots of different places all over the world for years and years and years, which will make your security people very happy. And so that's the core things I think you need to know right now. So if you're going to kick off a Hadoop project, what do you need to go? You need to go figure out what pig is. You need to go figure out what Hive is, and what have you. How do I process it? How we get in? Whatever. And yes, I will publish the slides. What else might you want to know that's sort of still pretty core? Disaster recovery, right? So maybe you've got your office up north in the Northeast and you don't have earthquakes and hurricanes. Oh, wait, you do have hurricanes now. We exported those from North Carolina to New York. You're welcome. So maybe you need disaster recovery. There are tools such as Falcon. You can do things like straight rsync and what have you and do straight replication of the file system. Falcon is alpha quality. It's not super mature. Workflow stuff. So Uzi is sort of a workflow for specific tasks. Flume is another more workflow for workflow implementation. If you're going to schedule, trigger, orchestrate ETL jobs and things like that, that's Uzi. Uzi, I will warn you, is terribly documented in that all of the examples in the documentation don't work. They will pass the command line validator, but not validate on the server and fun things like that. But you can make it work. It is a little immature. Install, configure, and monitor Hadoop. And this is actually, I think, what the Hadoop community should be most proud of, which is Ambari, which is an installer. You can actually, you do not have to write your own puppet. You do not have to go and manually install 1,000 data nodes or what have you. You just need to make sure that there's the Ambari user and the Ambari user has sudo on all these machines. And then you can say, hey, I want this stuff here, here, and here. And Ambari will work for most of Hadoop. It will not install Knox. And there's some other things it won't install as well. But at least for the core pieces of Hadoop, it will install that throughout your infrastructure. It also monitors and does configuration and what have you. Now, the configuration is not the most beauteous thing that handles everything with a happy little wizard. Some places, the way it handles configuration is you get to add a Java property, type the property name in, and type the value, and then it will deploy it to all of those different servers. But at least it does that basic initial install, configuration, what have you. It is not always great for reinstall or reconfiguration or what have you. Some of that is handled pretty shakily, meaning if you forget to install the pig client on all of the nodes you wanted the pig client on, it's not really a straightforward thing that you can do through Mbari, so beware of that. Some things are easier done at the start. If you want to use, this is actually something that's sort of annoying, I find, which is that pig and hive. I actually wrote an article about that like last week or the week before in InfoWorld called 12 Things I Hate About Hadoop. And one of them is I hate hcatalog, that I hate that I need it, which is you can use, if you create a table in Hive, you can't use that table from pig or from other tools unless you instead create the table in hcatalog, and then you can use it throughout. But all hcatalog does is serve that purpose. So why can't I just use the Hive tables? Why do I have this separate thing? But you have it and you must use it. And so create all your tables, not in Hive, but hcatalog, because chances are you'll need them later somewhere else. This is you can't see this as well as I'd hope. This is a screenshot of Mbari. It's got a dashboard up and it's got, how I/O bound I am and what have you. It looks pretty. This is Hugh editing a query, and that's really blurry. That's a select statement up there. But it's a web-based sort of GUI for Hadoop. This is Hugh editing Uzi, and it looks like a state diagram in essence. It's really crisp and clear on my machine, but it's really fuzzy up there. And this is a pig script, just so that you get a feel for the language. I didn't do the Hello World one. I thought, okay, you've probably seen the Hello World pig script and still don't know what the hell it is. So this is me loading files from a parameterized file path. So at the command line, I've passed the file path or through Uzi. It's a delimited file. This is actually like my favorite part of pig. Is somebody was a genius who wrote this CSV Excel storage. It is the CSV format as Excel might store it. So it has like multi-lines and all that kind of stuff, all that parsing already set up for you. Because I was about to write that thing, and then I was like, wow. And it had nothing to do with Excel. I took a sample from a real project and obfuscated it, changed the table name and what have you. It had nothing to do with Excel. It was just that the extract format happened to have multi-lines and all this other crap, and it happened to be similar to how Excel would output it. But this is using a delimited file, delimited by the 1 alpha character. I first set up how many things are in that array. So I load basically, Pig works with bags, so I load the bag up into an array of 10 elements for this particular table. This is actually auto-generated code. I wrote a generator to read an Excel file where they had their table names and column names and just generated these. But I went ahead and, normally you would name these, but since this was generated code, I didn't put names, I just put A0, whatever. And then I referred to things by $ whatever, which is the position in the file format. Normally you might put A1 through whatever here, or whatever you name those. You would put a real field name instead of A1 or what have you. This is just, for every row that was in the file, I'm generating something in my new bag with the column names from my Hive table. And then I'm storing it using this hcat store into an hcatalog table. And it's called orders, and it's in the stage schema, in the stage database in Hive. And this is a partition, which we're not going to go into great detail, but you can partition your tables. And here I've partitioned them from the date I got this extract. So that's roughly what a pig script looks like. So I can do weird transformations. basically it's sort of a, like Perl and SQL had a baby. And I say that in nice ways, and I say that in mean ways, both at the same time, and it is all those things. So you can do groups and all those sorts of group by statements and all those sorts of things in Pig, but where I'm loading it doesn't necessarily have to be a table, and generally it will not be. It'll be a file. All right, so I left, I think I left, or I intended to leave, time for questions, comments, social criticisms. No questions? I've covered everything.
Yeah. When you use Hadoop as for integration space and you start exposing all these different types of services and data as a service, any recommendations for how you would manage that?
So if you're doing different types of data integration, in a lot of cases you're going to expose it with a BI tool like Tableau or something like that. If you're doing a more sort of service-oriented architecture and what have you, then it really isn't that different. What you do want to avoid doing any fine-grained services, because why would you put it on Hadoop if you were doing fine-grained services? You would really only do coarse-grained analytical type services here. So I'm not going to create the lookup one order service on Hadoop, because I'm not going to look up one order on Hadoop.
Could be other services doing that based off the information from Hadoop? Fine-grained?
Really, if you're looking up one order, that's not really a good Hadoop problem, right? That's not an analytical problem. So